Hey, we we are looking at lesson 13.1, volumes of prisms and cylinders, and I found this really super funky work of art on the picture on the internet here. We have a chandelier. This is I don't think it's made completely of prisms and cylinders, but it's pretty much prisms and cylinders. And if you look here, the same thing, a little more close up on the chair. Obviously, I don't know what you can see there. That is, the outside is definitely a prism. And they kind of have some other ones with a little cutout, but if the piece were complete, it would be a prism. All right, and then there are some cylinders in there. Like right there, I think there's a cylinder. Anyway, very cool, very funky. I don't know if I really want to sit in it. I think the chandelier would be pretty incredible. I hope that's not real flames. All right, enough of that. Let's get on to the heart of the lesson. The formula for the volume of a prism, the area of the base times the height. And there's not much else to say other than that's what it is. And you just have to be careful when you see that capital B, remember that's the area of the base. So you may have to watch out for hexagons, pentagons, triangles where they don't give you the base and the height. You may have to go back to your 1/2 AP sometimes. Use that formula. The height is pretty straightforward, and that will get you the volume. That's for a prism. For a cylinder, the same thing. It's still this formula. The only difference is that since it's a cylinder, your base is a circle. So then you have the volume is equal to pi r squared times the height, or pi r squared h. And that's your volume of a cylinder. It's technically the same volume, it's just that you have different bases to work with. Moving on here, we're going to talk about oblique cylinders. I think I mentioned oblique before, but what does that really mean? This comes from a guy that discovered this. His name is Cavalieri. So it's Cavalieri's principle, not super important to know. So let's go ahead and look at an oblique cylinder so we can kind of figure out what that actually is. This is called a right cylinder. As best as I can make it, it's not a perfect right cylinder, but yeah. This is my fear that this was not gonna. It's supposed to be a cylinder straight up and down. Pretend like you'd be doing class that this is right up and down. When it's oblique, and now think about the volume of this. This has a certain volume. If it's oblique, it's gonna do this. Oh, give me a second here. That is an oblique cylinder. Did the volume change? I know you're thinking, oh, I didn't see it for a second. Maybe she changed the volume. No, I did not. Right, oblique, oops. Oblique, right. And the idea is that the volume of this did not change between the two. It's the same amount of little discs, so the volume has to be the same. The volume is the same between an oblique and a right cylinder, assuming, of course, the height is the same. Let's go ahead and, this is a prism, nice little book here. And everybody's kind of done this with a book, I'm pretty sure, sometime in your life. Look at, these are all supposed to be right angles here. Woohoo, woohoo. And now I'm going to make it oblique. Okay, notice that this is no longer right angle when I do this. Right, to the best of my book holding ability. Oblique. You can also see it on that end. Of course, it's curved a little bit. I don't think I can do it this way. There's a little bit. Oblique. Right. All right. So what's the point of that? Let's move on so you can see. And this is another picture to kind of puts this in much better perspective. The two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So this stack, if you move it over a little bit, this is oblique, you have the same exact volume. All right. I think we're going to go ahead and try to do the example problems. Find the volume of the triangular prism. Okay? So we need to find the area of the base. volume is, in this case, your base is going to be 1/2 base times height. And you're going to take it times the height. Now, look at this. You've got 2 h's in there. So be careful. The height with the first one is the height of the triangle, or the height of your base. And this is the height of your prism. So I'm going to have 1/2. This base, I don't know. So I'm going to have to do a little work to figure it out. This is 30. This is 30. So I'm going to take 30 squared. Uh-oh, I have my calculator on. 30 squared minus 18 squared. Take the square root of that. I get a 24. So I have 1/2 times 24 times the height, which is 18. I'm going to take that times the height of the prism. That means the distance between these bases. This is the base, this is the base. How far is it from here to there? 15. Okay, so now I take 24, or 1/2 times 24 times 18 times 15, and I'm getting a volume of 3,240, and this would be inches, and now that it's a volume, it has 3 dimensions, length, width, and height, then I have inches to the 3rd power. Next example. This would be example number 2. Find the volume of the cylinder to the nearest 10th. Once again, this is our basic formula. But since my base is a circle, I got pi r squared h. So I've got pi times radius, which is 1.8 squared, times the height, which is 1.8. Then you calculate. I got that rhymes. That's hilarious. Whoops. 1.8 squared times 1.8 times pi gives me 18, and I can round to the nearest 10th. So 18.3, is that weird? We got a 1.8, 1.8, and then an 18.3, and then centimeters cubed. Oh, this is from, obviously, I meant to take that off, but I wasn't planning on videotaping 2 in a row. Don't worry about Lane Rogers. Find the volume of the cylinder to the nearest 10th. Okay, I need a radius. Oh, but how am I going to find the radius? I'm going to need to find the diameter first. And Pythagorean theorem. 17 squared minus 15 squared gives me 64. Well, the square root of 64 is 8. So that means this little piece down here is going to be a 4. So I've got a radius of 4. Once again, I'm going to use pi r squared h. My pi, radius squared, the height of the whole cylinder is 15. So here we go. Pi times 16 times 15, and I'm rounding to the nearest 10th, 753.98, which I'm going to have to go ahead and rewrite as 753 to 754.0, because I'm showing that, hey, I actually know it's a 0, and I have a feet cubed. Okay, example number 4. Find the volume of the oblique cylinder to the nearest 10th. Okay, this is the height from here to here. Okay, we're not doing the slant height on this. The slant height is not the same as the regular height. You have to use your height. So I'm still going to use the same formula. So pi r squared times the height of the cylinder. Pi, the radius is 15. I'm going to square that. Take it times the height of the cylinder, which is 25. And then all we have to do is calculate. Does this seem a little easier? Did I only pick easy example problems and then your homework's going to be like incredible? All right, this is what I'm getting. The volume equals 17,671.5 feet cubed. It's a volume still. All right, can I get through one more problem? Number 5. Yeah, find the volume of the oblique cylinder. You know what? This will be your example problem to do, to turn into me. This is a wonderful opportunity to show me that you just watched the previous example and you totally know what you're doing. And I'm afraid of what I have on the next page because, once again, I wasn't like overly prepared. I'm going to sneak a little peek. Yeah, I don't want to put an assignment up there. But you are done. This is it. This is it for lesson 13.1. Uh-oh, there we go.